Welcome to our second video on ratios. If you haven't watched the first video on ratios, I recommend you check that out right now. In the first introduction video, you'll learn what is a ratio and get some examples on how to make ratios. In this video, we're going to practice with part-part ratios and look at some concepts behind simplifying ratios. So welcome to our second introduction to ratios. Let's remember what we learned last time. What is the ratio of circles to triangles? Remember, in order to find this, I count the number of circles and I count the number of triangles, and I make sure to write the relationship between those two numbers in the same order as it's found in the question. So circles to triangles is 4:3, but triangles to circles will be written as 3:4, and that word 2 is represented by a colon, one dot over another. Okay, so it should look just like this. That's your answer there. When we look at groups of items, okay, quantities that are divided equally into groups, we can actually just count the number of equal groups. Because each box has the same number of pens, we can compare the ratio of blue pens to pink pens by just using the ratio of boxes of blue pens to that of boxes of pink pens. So I see 5 boxes of blue pens and 2 boxes of pink pens. So the ratio of the number of blue pens to the number of pink pens is 5:2. In this case, we can count the boxes because they each have an equal number of pens inside. Let's look again at another example of ratios. When we wrote these ratios, we focused on the 3 green boxes of jam jars and the 2 blue boxes of peanut butter jars. But what if we didn't start by dividing right away? What would happen? Well, let's look at the number of jam jars. In each of those 3 boxes, there are 6 jars, so I can count that there are 18 total jars of jam. On the right side, we see that there are 12 total jars of peanut butter. If you haven't been able to count those, I'll give you just a moment to catch up. 18 jam, 12 peanut butter. So now, if we wanted to simplify this ratio, we would do it in the same way that we simplify a fraction. First, we look for the greatest common factor, then divide our numerator and denominator, well, in this case, that will be our first number and our second number, by that greatest common factor. So we need to find the greatest common factor of 18 and 12. Let's start with the factors of 18. 1 times 18 is 18, 2 times 9 is 18, and 3 times 6 is 18. So those are the factors we have to choose from. Let's look at the bigger factors, 6, 9, and 18. Well, 9 and 18 are not factors of 12, but 6 is a factor of 12. 6 is in fact the greatest common factor of 18 and 12. So we need to divide both sides of our ratio by the same greatest common factor. On one side we do 18 divided by 6, and on the next side we do 12 divided by 6. 18 divided by 6 is 3, and 12 divided by 6 is 2. So our ratio is 3:2. Now notice, we actually get the same answer as if we were to do just the boxes on their own. This means that we have simplified correctly. Okay? Now, Yen has been working on some of these problems as well, and she got stuck on a particular one. She was using our technique of counting the boxes of something or the groups of something to create a ratio. Let's see if she's correct, and we're going to explain why. So Yen looked at this picture and she noticed that there were brown eggs and white eggs. She noticed that the brown eggs and the white eggs were divided into equally grouped packages. How wonderful! She noticed there were 2 packages of brown eggs and 3 packages of white eggs. So she came up with the idea that the ratio was 2:3. Well, if this is true, then the ratio will work out even when we simplify, starting with the biggest numbers to make the simplest ratio, just like we did in the jam and peanut butter problem. So let's try that. Let's check Yen's work and see if the ratio of brown eggs to white eggs really is 2:3. Remember that a ratio of 2:3 means that for every 2 brown eggs, there are 3 white eggs. So let's check that out. On the brown egg side, we see 2 packages of 6 eggs each. There are 12 total brown eggs. On the white egg side, we see that there are 3 packages of 8 eggs each. There are 24 total white eggs. So in order to simplify this problem, we need to find the greatest common factor of 12 and 24. Let's start with the factors of 12. 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. Those are our factors of 12. Let's work with the bigger factors in this case, 4, 6, and 12. Let's ask ourselves if any of those are also factors of 24. Well, in fact, they all are. 6 times 4 is 24, and 12 times 2 is 24. So 12 is the greatest common factor of 12 and 24. That means that we're going to divide both sides of our ratio by 12 in order to simplify. So we start with the ratio 12 to 24. Visualize that as a 12 with a colon in the middle and the number 24. Now let's divide each side by 12. 12 divided by 12 is 1. 24 divided by 12 is 2. So we have the ratio 1 to 2. Uh-oh, that's different than what Yen got. But why is it different? Why didn't it work? I'm looking at the number of containers, and there are 2 containers on one side and 3 containers on the right side. What's different about what Yen did? What's different about this problem rather than the other problems we've seen? Let's look back. Well, something that was really important about this jam and peanut butter problem was that in every single crate, there were 6 jars. Okay? Not only were these jars equally grouped within the family of jam and within the family of peanut butter, but also between the 2 families, there were equal numbers of jars in every crate. Let's look back at the eggs. I'm noticing that on the left side, on the brown eggs, there are 6 eggs per tray. But on the right side, with the white eggs, there are 8 eggs per tray. Perhaps this had something to do with her problem. If there had been the same number of eggs in every single tray, then counting the number of containers would have made sense. But in this case, counting the number of containers didn't help us get to an answer faster. We had to look at the total number of eggs on each side and then divide by the greatest common factor to find that ratio. So be wary of these little tricks as you're looking for ratios. When we're comparing 2 things, we really need to look to see if they're equal or unequal. Now, I want you to try. I want you to find the ratio of the number of circles in this drawing to the number of triangles. Now notice, when you do this, you don't need to worry about the squares. First, count the number of circles, then count the number of triangles. And you can make your own ratio following the correct order and placing a colon between the 2 numbers. Next, you're going to find the ratio of the number of triangles to the number of squares. Now, in this second problem, the number of circles is irrelevant. We don't care about that one. We're only following the shapes that are actually mentioned in the problems. We're going to count the number of triangles, then count the number of squares, write them both down, and place a colon in the middle, always making sure we follow the same order from start to finish in our numbers as we did with the words. This is a part-to-part ratio. In every single one of these examples, we've been looking at some group of things and another group of things that are all part of a larger group. We've compared one part of that large group to another part of that large group. In our next video, we'll look at what happens when we zoom out and look at the whole universe of quantities that we could be looking at in ratios. I want to remind you that in this video, you learned about part-part ratios and how to simplify ratios using that greatest common factor. We also saw a bit of a trick where we need to make sure not to be confused and always know when to look for equal shared groups. Okay? So thank you so much for watching this video on Introduction to Ratios, and I'll see you next time.